Morning. We're talking with Seb Dewhurst. Seb is with EASA Corporation. And Seb, before we get too far along here, can you briefly give us a quick overview of your role at EASA, how long you've been there, your background, and so forth?
Sure. Well, my background, I guess you could say I'm a recovering engineer. My doctorate's in experimental fluid mechanics. I did my doctorate over in Oxford in the UK. Moved over to the States actually twice. Once for my internship, which was with NASA Lewis, actually now NASA Glenn, and then I came back permanently in '93 to work for what was then CFX. It's actually now part of ANSYS. So it was quite interesting using my kind of academic background in fluid mechanics, heat transfer, and being able to help customers solve real-world problems with CFD was just a lot of fun. Really enjoyed it, and had a great few years. But that experience directly led to the concept of EASA, because back in those days, we're talking, well, late 90s, the major CFD companies like CFX and Fluent were trying to find ways of making it easier to use what was clearly a very expert-only technology. I mean, we found ourselves selling literally to people with PhDs in fluid mechanics. That's a limited market, and in many cases, we found that companies wanted to be able to, execute the process more efficiently. So it's not just about the intimate knowledge of, in this case, CFD or the modeling technology. It's about the process of applying that technology to a problem. So we like to think in terms of processes here at EASA. It's not just so much about that underlying technology. So a lot of companies, as I said, like CFX and Fluent, were coming up with what were called at the time vertical applications, which basically means apps that had been built for a very specific industrial application, like, say, mixing vessels or combustors or pumps or something of that nature, where clearly the CFD engine was applicable, but you wanted to wrap it in a very application-specific graphical user interface. So that was beginning to happen. And there were various tools like Mix-Sim and tools of that nature. TurboGrid was one that we had within the CFX family of products, specifically for turbo machinery. And the thing is, though, building these tools was very, very expensive. And the other thing that we found is that most customers wanted a slightly different variant of that vertical application. You'd build a mixing vessel simulation tool, and the folks at DuPont would be absolutely wild for it. And then you'd go and visit the guys at Exxon, let's say, and they'd be like, no, our mixing vessels are slightly different. Yeah. And so without redesigning your software from the ground up, that was not a particularly viable approach from a business point of view. So we came up with this idea of EASA really before it had a name. And originally, EASA was actually just going to be an in-house tool that AEA Technology, the former parent of CFX, was going to use as a more economical way of building these custom applications. So really, you can think of it as kind of a low-code application platform, a low-code application building platform, well before low-code was a thing. I think Gartner, was it Forrester, coined the phrase low-code application development only a few years ago, but we here at EASA have been doing this for 15 years. And we've got customers that have been using it for that long as well. And so you can think of EASA then as a low-code application development platform designed specifically with engineers and scientists in mind. So it's a way to enable companies very, very quickly and easily to create custom wrappers that sit on top of, again, let's not think about the applications underneath, that sit on top of processes. They might be CAE processes, hardcore engineering design type applications. They might be preliminary design tools like Excel or MATLAB. And very often it's actually in that world between engineering and finance, where I like to call it where engineering meets dollars, where you'd really like to be able to make life easier for the folks that are actually selling or talking to customers, so our customers, and in many cases we find that Excel spreadsheets are being used here to form a link between all of that engineering knowledge that has been accumulated over many years and how that converts into a dollar amount. Okay, the customer wants this. That means the metal has to be this thick here, and we have to make it like this over here and like this. So if you've got a highly engineered or customized product or service, often we find that the roadblock to making the process as smooth as possible is actually not in a CAE application or structural analysis or something like that, because all of the analysis has already been done. It's about taking all of that knowledge and turning it into a price, and more often than not that's being done with Excel. And quite frankly, Excel has been an area that has enabled us to see some pretty significant growth recently.
Yeah, you mentioned Excel. I think I might be surprised at just how widely it's still being used, in today's digital world. Can you talk a little bit about that?
Yeah, I think it is fascinating. We engineers, we don't like to admit that we use Excel, right? Because we're rocket scientists. We use complicated stuff that nobody else understands. We don't use Excel. Everybody uses Excel. And so I think there's an element I do detect when I'm at the various conferences, NAFEMS conferences and so on, from some people that feel like, oh, well, maybe we use Excel, but it's a dirty little secret. We don't talk about it that much. When in fact, and I mentioned NAFEMS have done a superb job of really shining a bit of a light on this, for want of a better word, dirty little secret. They've done a pretty extensive survey, and I think they're in the process of publishing this information. There was a preliminary paper given a couple of years ago, but I think they're presenting a full paper, hopefully this summer's session. And the fact of the matter is that the use of Excel is growing. It's not, even though we've seen, computer-aided engineering software is, has grown dramatically. The technology has grown, in leaps and bounds over the last 20 years. Not least of which is the pure processing power that we have available now that, on your desktop that, 20 years ago, you'd have needed a Cray to do that kind of number crunching. So that has made a lot of the kind of calculations much more feasible. But the fact of the matter is, despite all of that, there's still a need to do these, I guess what we used to call back of the envelope calculations. Will it, does it violate the laws of thermodynamics? Will it fly? Will it break? Before we start getting into detailed design that of course does need advanced CAE tools, fluid dynamics, structural analysis, crash simulation, vibrational analysis, all the cool stuff that that produces all the wonderful graphics that we love to ooh and ah about. But the fact of the matter is, 9 times out of 10, a lot of the preliminary design has been done with tools like Excel and maybe MATLAB and other, homegrown scripts and stuff of that nature. And so the research that NAFEMS and others have done shows that the use of Excel is actually increasing. And to take a step back just from the engineering world, I think that's true everywhere. By virtue of our interaction with Excel, we have quite a few customers in the financial services sector. They use Excel almost exclusively as their modeling technology. Although we are seeing a bit of Python emerging now, but Excel is still the dominant modeling tool across, if you move beyond just the engineering and manufacturing verticals, Excel is the modeling tool of choice. And it's getting better and better. If you look at just in the last couple of years, we've seen, the release of Lambda functions, the ability to embed Java, instead of VB. VB is obviously pretty limited in terms of extensibility, but Java is pretty capable. And so we're seeing Microsoft pouring billions of dollars into this already very capable tool, which is one of the most widely used bits of software on the planet. I think it'd be very foolish to ignore, if you're looking at if you're responsible for the software tools that are being used within your organization, why wouldn't you treat Excel as, as a fully fledged citizen? You should not be ignoring it. It's there's a lot of money and knowledge and intellectual property wrapped up in some of these Excel spreadsheets. And you should be treating Excel as a true enterprise application, which, of course, when it's paired with EASA, it can be.
You earlier talked a little bit about low code development and might have touched on web apps a little bit. Can you talk a little bit about maybe how these translate well into the democratizing simulation theme, and maybe also while you're on that topic, why EASA, thinks it's important to participate in Rev-Sim?
Sure. Sure. Well, I mean, obviously, first of all, it's our heritage. Even though these days we get, the software is being used by customers, as not just in the manufacturing engineering sector, but also in other areas, like as I said, financial services and so on. But our heritage, obviously, is the engineering sector. That's where we came out of. And the whole concept of democratization was what originally drove EASA, and we're still seeing customers do that. And I think, to take a step back, looking at ways to democratize simulation, there are obviously the multiple ways, approaches to do this. One way, of course, is to take simulation tools like CFD and FEA and simplify them, embed them in CAD packages, for example. And we've seen that approach with folks like CF Design and folks of that, approaches of that nature. And that approach has its place. Often, though, the problem is that the level of simulation, supposing you need to do, say, a multi-phase simulation, well, trying to make that available, with that level of complexity within a general purpose design tool is kind of a recipe for disaster. So I think what we see emerging in the democratization approach, and they're both equally valid approaches, don't get me wrong, I'm not saying one is better than the other. I think they both have their place. One is the simplification. I'm not going to say the dumbing down, that's not the appropriate phrase, although I've heard that phrase used, but the simplification of simulation tools such that they can be easily embedded into design tools, so that designers and preliminary design folks can actually do some preliminary simulation to make sure that they're on the right track before perhaps it's handed over to the simulation group to do the more in-depth simulation. That's perfectly valid. EASA is obviously a proponent of the other approach, which is this templatization approach. It's basically saying, take the model in all its complexity. Doesn't matter if it's got multi-phase, combustion, plastic deformation, whatever. Complex modeling. It might be a modeling process that involves multiple steps. You do grid generation here. You do your solver is this, you then generate a bunch of charts and graphs, you then loop or maybe do some optimization, maybe a Monte Carlo simulation, you maybe dump some results out into Excel and do some slicing and dicing, whatever. So you've got a process. Well, obviously the only way really you're going to simplify a process like that is with an approach like EASA's, which is to templatize that approach, if it's possible. It's not always possible. To templatize the entire process and put a wrapper, a fit-for-purpose, highly task-specific GUI on top of that. And in order to do that cost effectively, of course, you've got to have a low-code platform like EASA, because if you're going to code something like that up from scratch, it's just going to be cost prohibitive in almost all cases. And this approach, this templatization approach, has of course become a lot easier as a lot of the solver technologies and have become more automatable, if that's a word. And we've got various other technologies to thank for that. The folks at ARIS, that have been developing the more, automatic, the ability to drive processes automatically, make sure that they don't break, to make them not so brittle. This is great from EASA's point of view, because it means that it's easier to build an app that sits on top of that process and can drive the process from beginning to end and make it, in that sense, democratized. So, like I said, I think there are two very valid approaches to democratization. EASA obviously is an example of the templatization of your underlying model rather than the simplification of it. But I think they're both equally valid. And I think one of the hidden aspects of the templatization approach is that there is often much more to the modeling process. Again, we come back to that word process. Then it's not just about running the grid generator and then running the solver and getting a result out. It's how do you use that? You know, how do you apply that? You know, if you don't know how to apply that, then getting that number isn't going to help you. So it's casting the entire process into an app that allows whoever the audience might be, it might be a designer, it might be a marketing, you know, we've had customers build apps that are that are driving complex engineering processes, and the end user is a marketing person, someone who knows what the market wants and wants to know if they can actually design something that will fit that requirement based on, you know, hardcore engineering modeling. So I think, you know, I think that we see, coming back to the final part of your question, I think Rev-Sim is an important organization because it's really a kind of you know, NAFEMS as an overarching, you know, organization to look at computer-aided engineering and simulation modeling is excellent. It's an excellent organization, but the democratization bit is really kind of a fledgling movement, if you will. And I think more and more people are recognizing that, oh, you know, it's the way of the future. I mean, most technology, if you think about it, has become democratized. So, you know, Malcolm Pathanki from ARIS always talks about, you know, how a few years ago a GPS system was something that, you know, you had to be, you know, it was something that fit in a van, and you had to be a military unit in order to take advantage of a GPS system. Now, of course, we've got them on our wrists. Okay. So that's democratization. It's just a kind of a, you know, it's something that you can't fight, really. It's going to happen. So how are we going to apply it to engineering simulation?
So yeah, obviously, you know, things have come a long way in a short time, as you just kind of alluded to there. But what challenges or barriers do you see is still being in front of us as far as democratizing simulation goes on a more widespread adoption level?
I honestly think the biggest barriers aren't technical. I think, quite honestly, they're psychological. I think that, and what I mean by that is resistance to change. You know, we've got some forward-thinking customers that have been applying EASA. Some of our customers go back to the early 2000s, and they're still customers day in, day out, using the software to, you know, to automate and accelerate these processes that would otherwise be quite, you know, expert only. But I think the biggest obstacle is that, quite honestly, it's just too easy to get caught up in, well, this is the way that we've always done things, the status quo. And, you know, we engineers like to think we're forward thinking, but I suspect that we are, just like the general population, in many respects, quite careful about, you know, about moving forward and you know, delegating technologies to people, you know, that we're not sure. You know, there's this kind of overriding concern that, you know, I hear, again, you know, sitting at lunch at NAFEMS and talking to, you know, industry leaders in aerospace, in automotive, and in all kinds of different industries. And they all kind of agree that, you know, democratization is a good thing, and yeah, we ought to do that, and we ought to look at it. But then when push comes to shove, no, we want our simulation to be done by people who have been doing it for 5 or 10 years and have had, you know, a grey beard in simulation, looking over their shoulder for the first 5 years of that kind of thing, because it's a complex subject and you can get it wrong. And if you get it wrong, then, you know, things will break or crash, and you know, and people will die. So it's an understandable, you know, the reticence to completely just jump into something new. It is totally understandable. So I think then, given that, I think then the biggest barrier is to help industry leaders, the people making the choices about what kind of simulation tools are used, is to help them understand how they can apply democratization safely to those areas. You know, you're not going to give a, you know, a novice designer the ability to design a new airliner. You know, that's just ridiculous. Yeah, but there are parts of the process that can be safely delegated to junior designers rather than having to be a senior simulation modeling person, running a simulation manually each time.
Yeah, so
So I
you're
think
saying it also, from what I gather you're saying is it also enables you to kind of use your expert resources in-house, to more of an advantage and on some of the more complex projects and so forth.
Yeah, I think it's a case of we have a graph that we use that shows, it's a pie chart. It's really simple, and it's just a very simplistic idea. It's just to get across a concept. It says, so okay, if this pie is all of the modeling and simulation that you do within your organization, maybe only a tiny slice of that pie, maybe 10%, pick a number, but a small percentage is templatizable and appropriate to be democratized and delegated to other people other than your elite simulation guys that know how to use simulation tools. So maybe there's a very small subsection of all of your simulation that fits into that category. And I think that a lot of CAE leaders kind of know that inherently. They know that, well, most of our simulation doesn't fit into that. We can't templatize it. It's going to be ad hoc. It's going to need an expert. When, for a few % of our simulation, is it really worth looking at a democratization platform like EASA? And the fact of the matter is, if you look at companies that have done that, I mean, that's an understandable approach to take. It's an understandable reaction. But if you look at the companies that have said, okay, let's give it a try on that 10%, what happens is that the 10% of that simulation, it actually starts growing, because once it's democratized, of course, people can start running more simulations, therefore finding better solutions more quickly, more cheaply than would have been possible without appropriate democratization strategies in place. And so all of a sudden that 10% starts gaining weight, if you will. It's still, it's not going to displace the other 90% of the simulation that still needs to be done, quite rightly, perhaps by experts. But now all of a sudden, you're getting quite a lot of simulation being done by people who are not experts, therefore taking some of the pressure off your expert simulation guys, and you're getting good results, and you're finding solutions that you wouldn't otherwise have found, because they're able now to run multiple simulations very quickly and easily, and iterate towards better solutions. And so if we've tried to do kind of an analysis of customers that have taken that approach, and what we see a couple of years on is that now, if you just measure in terms of the number of simulations that are being run, that what was 10% is now more than 50%, because even though it was only 10% of your simulations, people are being able to hit those simulations again and again and again and iterate towards better solutions. Now, more isn't always better, I grant you, but what we are seeing is that companies are coming up with solutions by virtue of democratizing some of their processes that they would not otherwise have come up with.
Those are excellent points, Seb. Our time's kind of getting short here, but I want to circle back to something you brought up earlier, the template approach. Without naming names or getting overly specific, can you talk about maybe some of the results that have come from that, from EASA's perspective, some of what your customers have achieved?
One of the downsides of working with customers here at EASA is that they don't like to share what they do with the software. And if you think about it, if you think about what EASA is, it's a tool for building tools, and it's a tool for building highly proprietary tools that are completely focused on the workflow at your particular company. So, you might talk to, a Boeing or a Ford or something like that, and, you can get them to admit that they use, Fluent or ANSYS or something of that nature. And they might make a few general statements about the kinds of analysis they use, because let's face it, anyone can kind of figure that out and reverse engineer that, companies such as that will be using tools such as this. But when we get into what customers do with EASA, they tend to keep it pretty close to their chest, because they're building proprietary applications that are specific to their workflows in their companies. It's literally it's their secret sauce of what makes their company competitive or better than their competition.
No,
So
I
that's
get
hard to do. Having said that, we do have a few case studies on our website, easasoftware.com, and there's some great case studies there from the likes of Ingersoll Rand and General Electric and a few others. And then we've got some talks from folks like Schneider Electric and Pfizer and people like that, where they dive into the kind of benefits. And in some cases, they're able to quantify the benefits, but it is very, very dependent on the kind of apps that are being built, I will say.
Understood. So anyone interested can we'll refer them to your website. I think there's also some case studies that we've got on Rev-Sim, and we'll direct people to your website as well. Mm-hmm. If anyone has some questions, wants to get a hold of you, what's the best way you recommend they do that?
Yeah, absolutely. Just drop us a line at info@easasoftware.com or head on over to our website, easasoftware.com. There's a contact page there with phone numbers both for the US and the UK. We have offices here in Tampa, Florida, and in Pittsburgh, Pennsylvania, and also over in Oxford in the UK. Those are our three main offices. So that covers, most European and US time zones. So just give us a call or drop us an email at info@easasoftware.com.
Okay, fantastic. And before I let you go, I've got I think I've seen a picture of you flying a plane or something like that. Can you talk about maybe some of your hobbies outside of EASA?
Sure, I certainly can. Yeah, I mean, that goes way back. The flying habit started a long time ago, back at high school in the UK. I joined, I suppose the closest equivalent here in the States would be the ROTC. In the UK, it's called the ATC, or Air Training Corps. So every Wednesday afternoon, I would get on my bike and cycle down to the local Royal Air Force base, which was literally 2 miles down the road from my high school, and go for flight training in the little de Havilland Chipmunks were the planes that we were flying. And pretty soon they'd let us go fly solo. So I was flying a plane solo before I passed my driver's license, which is slightly ridiculous, but there you go. And the bug bit hard, and back at the age of 17 or 18, if you had asked me what my career was going to be, I was looking for a career in the military. I really wanted to fly Harriers, was my big thing. Had a thing for vertical takeoff, but I failed an eye test, and so those plans went south, and I followed my path through engineering, and no regrets at all. Still carried on flying, and I eventually scratched the vertical takeoff itch when I moved to Pittsburgh many years ago. I actually got my helicopter rating, and
nice.
So yeah, I love flying planes of all different types.
And also, I think I've seen where you do some mountain biking as well. Is that
actually?
Yeah, I went for video, something like that. Yeah, at one time.
I'm sorry, Rob, say the question again.
I believe I saw a video that you recorded on a trail. It looked pretty harrowing.
Yeah, we have. You mentioned mountain biking and then say that you live here in Florida, and people look at you kind of funny because, obviously there aren't that many mountains here in Florida. But what there are a lot of is reclaimed phosphate mines, which have the state has allowed to return to their natural kind of state. And it's a hell of a workout. There's some, you obviously don't get the continuous climbs that you would get in mountainous regions, but you get some highly technical stuff. I actually went for a ride this morning before breakfast, and feels good. An hour on the trails, and you're definitely set up for the day.
Sounds great. Thank you. Seb, appreciate your time this morning. Again, it's EASA.com if anyone's interested to learn more.
EASAsoftware.com.
EASAsoftware.com. Thank you. And you can also find a link to Seb's LinkedIn profile and the company on Rev-Sim.org. If you happen to be, after you watch this video, if you want to take a look around, you'll find some information about EASA and Seb there as well. So, Seb, again, thank you. Appreciate your time. And maybe we'll do it again down the road.
Absolutely. Looking forward to it.
All right. Thank you.
Cheers, Bob.